Okay, for number 8, it says use the previous equation, find the slope, interpret the slope of the line of best fit. So the previous equation was in this blue box, y equals negative 25x plus 170. So our slope is negative 25. Okay, now what does it mean in this context? Some of you guys did not actually answer this question on the quiz. Like you told me what slope is in general, but the real thing we're trying to do is interpret the slope within the context of the problem. So the slope is negative 25. This means the remaining distance is decreasing by 25 kilometers per hour. Remember, when we talk about slope, we're talking about the change in the y values over the change in the x values. So the change in the y values would be a change in kilometers. Okay, and it says remaining distance on the y-axis. The x-axis, it says it's a time in hours, so it's a change in time in hours. So when we talk about rate of change, we're comparing the change in kilometers to the change in hours. So some of you guys might be thinking that like it's confusing to try to figure out what it's interpreting by. But what we've showed you is that every time you're trying to interpret the slope, you are using these values, labels on the x-axis and the y-axis. So if my slope is negative 25 over 1, then we're changing the kilometers by 25 and we're changing the hours by 1. So it's decreasing by 25 kilometers per hour. For number 9, it says connect the R values with the corresponding scatter plots. So I've already done that. This one has an R value, the top one, of negative 0.95. That's because these points are pretty close to the line. The closer they are to all being on the same line, the closer the R value is going to be to 1 or negative 1. The 1 or negative 1 just has to do with whether it's positive or negative. Since this line is decreasing or going down, it's going to be negative. And it's all those points are pretty close to the line, which is why my R value is so close to negative 1.0. These points are pretty close to the line, but definitely more spread out than the top one. It's also a positive sloped graph. So the only positive choice you guys had was R equals 0.80. And again, just to see the difference between 0.8 and 0.95, 0.95 is closer to negative 1, so those points are closer to the blue line. 0.8 is not as close, so the pink points are not as close. If I drew a line of best fit for the purple looks even more spread out than the pink. So the purple is going to have a value that's even further away from 1. So that's negative 0.78. So even though it's still a pretty strong predictor, a strong correlation, it's weaker than the other two because the points, the purple dots, are a little bit further away on average than the pink dots and more than these black dots on this blue line. For number 10, it says a weight loss chart. And the question is, this scatter plot has what type of correlation? So this scatter plot has what type of correlation? Strong or weak, and positive versus negative. So if I had to draw a line through the dots, okay, that might not even be the best one. Maybe we have to move that a little bit. Okay, not sure there. Either one might be okay. But it's definitely negative because the line is going down. And then is it strong or weak? That means are the points really close to the line or are they kind of spread out? They're really close to the line. So strong negative correlation. For number 11, you're given the same graph. It says weight loss chart. On the y-axis, we have pounds. So I assume that's how much someone weighs. and then time in weeks on the x-axis. Interpret the slope of the line of best fit. So the slope is -2. And if we use our words, we're looking at a change in weight, pounds, compared to a change in time, weeks. That's going to be my slope, my rate of change. So if we say that this is equal to -2, that means that my weight is changing by -2 pounds for every 1 week, or that my weight is going down by 2 pounds a week, or you're losing 2 pounds each week. Because you're trying to lose weight. It's a weight loss chart. And finally, number 12, with the weight loss chart, it says the line of best fit for this equation is y equals -2x plus 180. Use the equation to predict the person's weight after 9 weeks. So please notice that the graph doesn't go out to 9 weeks, right? It goes out to 7. So then this would be 8, and this would be 9. So they're asking you to make a prediction about how high this would be after 9 weeks. And we can't really tell exactly from the graph because we don't know based on the graph whether, like, if this is my line, if my line's a little bit less steep or a little bit more steep. And it says use the equation to predict. So if I use the equation, I'm going to say that y equals -2 times 9 for 9 weeks plus 180. So after 9 weeks, we're letting x, which is on the bottom, right between the 7 and the 8, we're letting x equals 9. So that means that y is going to equal -18 plus 180. So y is going to equal 162. So we might be able to guess that from the graph, but using the equation, it's going to be 162 pounds. And since we asked you to use the equation, that is the only correct response. So when we ask you to make a prediction using the equation, we want you to do so. Sometimes we ask you to make a prediction using the graph. That's it for quiz number 5. Thank you.